Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialists. All right, so wasn't that an amazing session?
Hey everybody, I don't even know what you can hear and what you can't. It appears like we're having tech.
Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello again. We had some technical difficulties at the beginning of that broadcast. As Dr. A said, I'm Amy. I am one of the math specialists here at the Learning Liaisons, and welcome to Wednesday Night Math, where we keep it real here. I was trying to go live. It wouldn't let me go live. Then I clicked on shooting it over to him, but then it went to me, but then it went back to him. So we are here now. We are ready to do math. I'm excited. It has been a day at the school that I'm at. Our power went out today for a while because a transformer blew for no reason. I mean, obviously there was a reason, but it wasn't raining or anything. So, it's a fun day. But I am excited to be here with you guys. Thank you, Donna. Thank you, Terry, for keeping me updated on what was going on the screen. I appreciate that. Hey, Hope, it's good to see you. So before we get started, I always like to start with an introduction, just to get to know who's in the room. So let me know where you're from, what test are you prepping for, and I always like to do a fun question just to get to know everybody. So where are you from? What test are you prepping for? And regular Oreos, double stuffed Oreos, or the most Oreo? Have you even tried the most Oreo? I am gluten-free. I am highly allergic to gluten, so I can't try the most Oreo, but they do have a double stuffed gluten-free Oreo that is amazing. My husband even says it tastes like a normal Oreo. So are you an Oreo person? And if so, are you a double stuffed, regular, or the most Oreo kind of person? We are doing a March Madness Oreo flavor bracket at my school, and it is so fun. So all that said, welcome. Good to see you. Hey, Joseph. The original Oreo, Donna. Yes. Double stuffed. Joseph, you're my kind of girl. I like the extra cream, so I feel like if I could eat the most Oreo, I would really enjoy it. No, you missed it by 2 points. You were so close. Oh, I wish I could give you a big hug right now. That just makes me so sad when people I love miss the exam by that much. Someone I know missed it by 1 point this week too. Like 1, 2, like, oh, I'm so sorry. And I know that you have been trying so hard. You've been putting in that work, and that's all that matters. You've got this. Remember, it's when you pass, not if you pass. Hey, Hope, good to see you again. Terry, double stuffed Oreo, awesome. And I'm glad to hear that it has helped. That makes me happy because this is for you guys. So, all right, let's go ahead and get started with our first problem. I do have a good chunk of problems tonight that are directly from specific requests people have made. So I like to start off by saying, if there is any questions you have, please let me know in the comments. And if you have anything that you want to see me go over in the upcoming weeks, please let me know in the comments as well. So if there's anything you want to see me going over, or if you have any questions at all, let me know. I do build my slide decks based on what you guys need. So let me know in the comments what you need. Without further ado, let's go ahead and get started. Problem number 1. The position of a particle can be defined. Is this the right? This is not the right presentation. Let me see. I am so sorry. We're going to switch. I have the wrong presentation pulled up. I was like, that does not look like the presentation I put together today. So let's see. Here it is. Whew, I was like, I don't have the right presentation. This is going to be a problem. All right. There we go. This is exactly what I was looking for. All right. Problem number 1. So last week we solved this problem. You're trying to scare us. I'm not trying to scare you. I promise. And hey, Milagros, missed you too. Glad you're feeling better. Do I have tutoring available on Sunday? My account on our Learning Liaisons page was not working for a while, so I am not sure if it's working at this point. So feel free to email me and we can touch base about tutoring. But if not, Priya is definitely available. But let me check my Calendly page and I will let you know. So email me. Okay. A painter is working on painting a house. He has painted 42% of the house so far, and it has taken him 11 hours to do so. How much longer will the painter need to complete the job? So we solved this very conceptually last week. And I had said that we could solve this using a little bit more algebra. And someone said, yes, please solve this using a little bit more algebra. So here's how we would solve this using algebra. We know that 42% of the job has taken him 11 hours. And we want to know how long it's going to take to complete the entire job. So if we define J as our job, like the whole job, then we can go ahead and move forward with thinking about how we're going to solve this. So if a painter is painting a house and he's painted 42% of the whole job so far, then I know, I'm pulling up my calculator, then I know that if it's taken 11 hours to do 42% of the job, and I set up an equation, I can say, if I know that my whole job is J and I multiply it by 0.42, how did I get 0.42? Well, I can take this percentage right here and convert it into a decimal by hopping this decimal place 2 places to the left. And that creates my decimal. Now, don't think that 134% would be 0.134 because it's not. The decimal doesn't just automatically go to the left of the number. We move the decimal 2 places to the left, so it actually equals 1.34. So just remember, 2 places to the left. So if I multiply the job by 42%, or time it takes to complete the job, what is that going to equal? How long does it take to complete 42% of the job? 11 hours. Now, I can divide both sides by 0.42. And J equals. Now, this is a problem that we would typically see on an elementary test. It could also be on a middle school or a high school or a GK or a Praxis core. This is one of those problems, those unique problems that could be on any of these tests. So with that said, if you have a 4-function calculator, this way is very simple. However, if you don't have a 4-function calculator, then this way becomes a little bit more cumbersome than the conceptual way we did it last week. So 11 divided by 0.42 in my calculator equals 26.19. Now, that said, if I didn't have a calculator, I would have to go ahead and do long division. What would long division look like? Well, I would do 11 divided by 0.42, but I would have to convert this out of a decimal. So I would have to move this decimal place 2 places over, which means I need to take this imaginary decimal and move it 2 places over. Whatever I do to one, I have to do to another. So that would equal 42 divided by 1100, and I would get the same answer, okay? Now, what does this number represent? This number represents the time it takes to complete the entire job. So this is not my answer because I then have to go and see how much longer will the painter need to complete the job. So how much longer will it take? I have to take that number and subtract the time that we've already done. which would be 15.19, which gives us B as our answer. Is this a proportion? It is not a proportion. I just took my understanding that I have a whole job. I multiplied it by the percentage that we've completed and set it equal to the time that it equals to complete that percentage. A proportion looks more like this, like the flagpole is, or let's relate it to this job. Job A takes 3 hours to complete and job B takes 9 hours to complete. If job A is 5 square feet, how big is job B if they are proportional? And then you would set it up like this, and then you could cross multiply. But that's not what this is. This is not a proportion. It's not really a formula that you can memorize. It's really more just an equation that we are setting up because we know that multiplying our whole job by a percentage is going to equal that whole that time frame that we have. Does that make sense? All right, let's go ahead and move on to problem number 2. Ooh, this is a good one. Hey, Susanna, good to see you. Jeremy creates an open box with a piece of 8.5 by 14-inch paper by cutting out 1-inch squares from each corner and then folding up the sides of the paper to create a box. He wants to color the outside of the box. What is the surface area of the box he created? Now, we did this problem last week too, except we found the volume of the box. And in this case, we're finding the surface area. So if you remember last week when we did this, and I'm trying to see if I have a piece of paper handy, we'll use this teeny tiny sticky note. So if you remember last week when we did this, I took my piece of paper and I ripped corners out of it. And when I ripped those corners out, it allowed me to fold them up and create a box. So here I am ripping the corners out of my piece of paper, 1-inch squares out of each corner. And then what that allowed me to do is create this box out of my piece of paper. So you see I've created this teeny tiny little box. Now, when we found volume, it didn't matter that we didn't have a top on our box, right? It did not matter that we don't have a top for this box. All we have is a bottom, a right, and a left. So here's my teeny tiny little box. You can see the edges. So if this is my box and I'm putting stuff in it, and this is a problem for tonight, it doesn't matter if there's a top, I can still fit the same amount inside of it. However, when I'm doing surface area, it does change the surface area because this is an open box. So if I am coloring this or painting it, how much surface area do I have is going to change because I'm only going to have the bottom, the right, the left, the front, and the back. I don't have a top, so I'm not going to color the top. This is a perfect example of why formulas only work 90% of the time. Formulas only work 90% of the time. Formulas work 100% of the time to find what the formula is telling you to find. But if I said, what is the formula for surface area? You would find something like this on Google. 2 times length times width plus 2 times length times height plus 2 times width times height equals surface area. You would find something to that effect. But that doesn't work for this scenario because I only have a bottom, a right, a left, a front, and a back. I don't have a top. So for some people, this is perfect because they understand how to use a formula. And they say, it's okay, Amy. I know we don't have a top, So if I draw my box, with no top, imagine that there's no top on this box, then they say, no worries, Amy, I totally understand it. We have a bottom, so we're going to call this the bottom. I do not understand. I've been so careful not to touch my screen today. I don't know why it keeps disconnecting. Like, I've been so careful. Let's hold it. Let's see if that works. Okay, so we have a bottom, but we don't have a top. And then we have a left and a right, and a front and a back, right? So if we have a bottom, a left, a right, a front, and a back, then let's call this the right and the left. So that's the right and the left. And then let's call this the front and the back. Well, we only have one of these, so then I could go ahead and do my formula. But sometimes that doesn't, people have a hard time conceptualizing that. So you can do it that way, or you can do it the conceptual way. I feel like we've had a lot of problems where we've done this. So first things first, we have to figure out the dimensions of our box because it's not 8.5 by 14. So if we have a piece of paper, and I already went over this last week, so I'm going to very quickly go over this part of it. And it's 8.5 by 14. And I cut out 1-inch corners from each corner. That means I'm cutting out 1 inch from the top and the bottom of each side. So that means this is no longer 8.5, it's actually 6.5. And this is no longer 14, it's 12. Again, if you need more of that explanation, you can go back and watch last week's. So this is going to be 6.5. This is going to be 12, and this is going to be 1 because my corners, when I cut them out, they were 1-inch squares, and when I folded it up, it's 1 inch tall. So that said, I know I can do 6.5 times 12 to find that bottom. So the way I do surface area is I draw all the possible shapes that this object has. So I know I have a bottom that is 6.5 by 12. And then I know I have a right and a left that is 1 by 12. And I know that I have a front and a back that's 1 by 6.5. I know I have 2 of these, 2 of these, and 1 of these. All this is the formula with pictures. So when I find the area of each of these, area equals length times width. Area equals length times width. Area equals length times width, right? Every time we're doing area equals length times width to figure it out. So when I do area equals length times width, wow, can't talk. When I do area equals length times width for all of that, then it gives me 6.5 times 12. I am going to use my calculator for this. $78. And I only have 1 of those. Then I have 1 times 12 is 12, but I have 2 of those. So that's going to equal 24. And then I have 1 times 6.5, which is 6.5, but I have 2 of those, which equals 13. So now I can add all of that up. 78 plus 24 plus 13 equals 115, which is A. Does that make sense? All right, if it doesn't, let me know, okay? Let's go ahead and move on to the next problem. A teacher is introducing her lesson with the following word problem. There are 9 students sitting at a table in the cafeteria eating lunch. Some more students sit at the table. Now there are 17 students eating lunch at the table. How many students sat at the table second? What kind of problem is this teacher using to teach the relationship of addition and subtraction to her students? This kind of problem was highly requested. It's this is classic elementary teaching pedagogy. So, and it's not really pedagogy, it's more like what kind of problem is it? But it's teaching, like, it's not like a true math problem that we solve, right? It's like a teaching style, teaching philosophy, all of that. So that said, we see these kinds of problems on Praxis, on FTCE, on TExES. Yes, Donna, I knew exactly that you were the person that I was building this for. And there was actually 3 other people that asked for this kind of problem. So when we look at this problem, there are 9 students sitting at a table in the cafeteria eating lunch. Now, if you don't understand the types of addition and subtraction problems that there are, and you are taking an elementary math test, you need to understand the kinds of problems that there are. It is not just there are 9 and 4 more join. There are a ton of different kinds of problems. So when we see these words right here, join, change, unknown, join, start, unknown, separate, change, unknown, separate, start, unknown. What I need you to realize is that most math problems can be solved in multiple ways. So I might solve this problem using addition. You might solve this problem using subtraction. But what you need to recognize is, how is the problem originally set up? So if there are 9 students that start at the cafeteria table, so here's our cafeteria table. And there are 9 students that start. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then some more students sit at the table. Are students joining, or are we separating the group? Are we getting more, or are people leaving? We are getting more students. Now, I do not teach word problems using keywords. That's another conversation for another day. We need to understand conceptually what the problem is asking. And if you want to know my philosophy on how to teach word problems, come find me on social media. But that said, we know that more students are joining us. So this is a join problem all day, even if you used subtraction to solve it. So if I set up an equation for this, we have 9 students and some more students join. And now there are 17 students eating at the table. How many students sat at the table second is my purple box. So this is a join problem, but is it change unknown or start unknown? What do we not know? You could also see join result unknown. So is the number that I started with unknown? Is it the number that has changed unknown? Or is it the result that is unknown? In this case, it is join, change, unknown. My starting number is this one. Start. My change is what is happening in the problem that is changing. And my result is what happened at the end of the story. If this was a separate, change, unknown problem, it might be something like this. There are 17 students sitting at a table. Some students get up. Now there are 9 students. Because students are leaving or separating, it's a separate problem. We started with 17. Some kids got up. We don't know how many, but I know my result. If it was separate, start, unknown, it would sound something like this. Some students were sitting at a table. 9 students got up and went to the bathroom. Now there are 8 students left. That would be start unknown. Separate result unknown would be there are 17 students sitting at the table. 9 students get up to leave. How many students are remaining at the table? Does that make sense? It's a lot of different vocabulary for one common, very, very common type of problem. But if you understand where the change, the start, and the result are in an addition and subtraction problem, you'll understand what we're looking at. Now, there's also comparison problems. So I have 4 blue cars and Sally has 2 blue cars. How many more blue cars do I have than Sally? That is a comparison problem. So that is not this kind of problem right here, okay? Okay, Donna, separate start unknown would be there are some students in the cafeteria. 8 students get up to leave. Now there are 9 students remaining in the cafeteria. How many students started at the table, okay? And separate result unknown, because that was the last one I did, would be there are 17 students sitting at a table. 9 students get up to leave. Now there are how many students sitting at the table? That would be separate result unknown. And if you want a document that explains all the different kinds of problems there are, I do have one, so you can email me at more_Amy@hotmail. That is not my email address, more_Amy@hotmail, and I'm happy to share that with you. All right, let's go ahead and move on to the next problem. A marine biologist is evaluating the population of nurse sharks in a specific area. Initially, he catches 300 sharks and tags them. 2 months later, he finds 120 sharks and 24 of them are tagged. He can estimate the population of sharks in the area is how many? So a marine biologist is evaluating how many nurse sharks there are in a specific area. And initially, he catches 300 sharks and tags them. And the tagging process in this problem is not harmful to the animals. It's a research-based process. I have to say that for myself. 2 months later, he finds 120 sharks, and 24 of those sharks are tagged. What is the population of all the sharks in the area? So there are 2 answers I can get rid of right away. It is not going to be 60. Why is it not going to be 60? Because the first time he went, he tagged 300 sharks. So we know that in that area, there are at least 300 sharks, right? So if we know there's 300 sharks in the area because he caught 300 of them and tagged 300 of them, then we know that 60 is not how many sharks there are because there's 300 that have tags on them. We can also assume that it's not 300 either, because 300 would be absolutely ridiculous if she actually caught all of the sharks. You know, like she didn't catch every single shark there was in that area. If she did, that's really impressive, but she didn't. So that's not a viable answer choice. So we're down to 2 answer choices just by using test taking strategies. And now if you don't know how to solve the problem, at least you have a 50-50 shot, right? Now, when I look at this, what I'm really looking at is what percentage of the sharks are tagged. Of the ones that he found? Well, what can I do to figure out the percentage that are tagged? Remember, a percentage is just a part over a whole. So if we call this the part and this the whole of this sample survey, then I can figure out the percentage. Now, again, if this was an elementary test, you don't have a calculator. If it's not an elementary test and you're seeing this on a GK or a Praxis core, you probably do have a calculator. So we're going to do 24 divided by 120. 120 can't go into 24, so I'm going to create a decimal. And 120 can go into 242 times with no remainder. So what is 0.2 in a percentage? I can hop that decimal place right back to the right. So hop, 20%. That means that 20, we can assume in this research study that 20% of the sharks are tagged because of this sample size right here. So if 20% are tagged, that means that this is 20% of the whole. So how do I figure out what my whole is? I take my whole, I multiply it by 20%, and it gives me 300. This is the exact same thing we did on that job problem earlier. This is the exact same thing we did on that job problem earlier. Divide both sides by 0.2, and W equals something. Now again, I have a calculator, so I can divide it out. If you don't have a calculator, you can do 300 divided by 0.2 and move that decimal. So you have 3,000 divided by 2, which tells me it's 1,500. Now again, there's other ways we can solve this problem. That's just the way I chose to. If this is not how you wanted to solve it, what could you do? Well, if I know that 300 is 20%, and what is a whole equal? 100%, I could have done 20%, 40%, 60%, 80%, 100%, right? 20 plus 20 plus 20 plus 20 plus 20 equals 100. And so I could have done 300 plus 300 plus 300 plus 300 plus 300, and that would have also given me the same answer. All right. As we are sitting here getting ready to do the next problem, I want you to think about, what do you want to see me solve next week and in the coming weeks? I did receive an email from somebody about an interest rate problem, but unfortunately, I didn't see it until whoever it is, you sent it like this afternoon, and I didn't see it until about 10 minutes before we're starting, and my PowerPoint was already done. I will absolutely include that problem in either next week or the following week's presentation. So don't think I forgot about you. I will absolutely include it in the upcoming week's presentations. Now, if you have anything you want to see me solve, please let me know in the comments. I'm more than happy to include that because these sessions are for you. Okay? Now, let's move on to the next problem. Ooh, this is for my high school people. We've done a lot of elementary today, and we will likely have time to get back to elementary, but I wanted a problem specifically for my high school people. An object is traveling through space with a velocity of v of t equals 4t minus 4. If at t equals 1, the position is 5, what is the particle's position at t equals 4 seconds? All right. high school people, 6 through 12, 7 through 12. An object is traveling through space. Now, this is a calculus problem all day. What I want you to understand is that calculus is typically only between 6 and 12% of your exam, give or take a few percentage points. So if calculus is something that makes your brain go, oh, and you do not understand it at all, I wouldn't suggest investing a bajillion hours in understanding that 6%. I would suggest investing your time in all of the other 90-something% of the exam that you do understand. If you have a conceptual understanding of calculus that makes sense, focus on it. But do not spend a bajillion hours learning calculus that you don't know for 6%. There's a lot more value on the test that you can get other than that. But if you do have a conceptual understanding for calculus, then spend the time learning it, because it can be an easy, quick few points for you if you do understand it. Now, velocity. Functions start with f of x, or your position function, and then it goes derivative and then double derivative. So if I take the derivative of my first function, which is my position function, P of t equals position. And actually, I'm going to use F just so that I can keep everything consistent. The derivative of F of t is going to be your velocity. And the second derivative of your position function, or the first derivative of your velocity function, is going to be acceleration. Elementary people, don't leave yet. I promise that I'm going to try to get back to some elementary problems. So if I have my position function is f of t and my velocity function is my derivative of that, then this is technically the first derivative of my position function. And I know I'm looking for the particle's position. So I know that I need to take the integral of the velocity function to get back to the position function, right? So I need to find the position function, which is going backwards from the derivative, right? So we know that using the power rule, we can derive a function. So I know that if this is t to the first, that this has to be t to the second. Because when I use the power rule, I drop that exponent in front and then I subtract 1. So if I'm going backwards, I'm going to add 1 to my exponent, right? And then if I drop this 2 down here and multiply it by something, it has to give me 4. 2 times what equals 4? 2 times 2. I'm going to do the same process for this. Minus. Now, this is technically t to the 0 power, right? So this is going to become t to the first power. And if I drop that 1, 1 times what equals 4? 4. But we also have a constant. And when we take the derivative of a constant, it doesn't exist, which is why there's nothing out here. So now you're like, great, why do I have a C in the middle of all of this and how do I find it? Well, I cannot find the position at t equals 4 until I find my constant. But what I can do is use the information they already gave us to find C to then find the position. So I'm going to take my position function, P of t equals 2t squared minus 4t plus C. And I'm going to plug in this information that they already gave us, right? So they told us that at time equals 1, the position is 5. So I can plug that in right here. the position is 5 when time equals 1. Now I can solve for that constant value and then figure out what the position is at time equals 4. So 5 equals 2 minus 4 plus c. 5 equals negative 2 plus c. Add 2 to both sides. C equals 7. So now I'm going to plug 7 in for c. And now that I have my position function, I can plug in t equals 4 in for t and find the position at t equals 4. So P of 4 equals 2 times 4 squared minus 4 times 4 plus 7. 2 times 16 minus 16 plus 7. 32 minus 16 plus 7. 32 minus 16 plus 7 equals 23. So the position of the particle at time equals 4 is 23. Susanna, got it. Praxis 7813, student errors with fractions. I'm going to go ahead and take a picture of that comment so I don't forget. Whoop. And I will add that into next week. Sound good? All right, let's go ahead and keep going. Now, I took 3 different calculus problems that were fairly quick just so that I could show velocity, acceleration, and position. So we already did position. Let's go into instantaneous velocity. So the position of a particle. So in this case, we started with the velocity function. So we started here. But this time in the new problem, we are starting with our position function. Can be defined as x of t equals 0.34 t to the 3rd power plus 2t. Find the instantaneous velocity of the particle at 3 seconds. I wasn't even touching my iPad and it disconnected. Donna, how did I get C equals 7? You do not need to know how I got C equals 7. On K through 6, you will not see any calculus problems. I can assure you of that. None of what I just went over is on your blueprint. So you do not need to worry about that. All right. So this problem, Donna, and the next problem, you do not need to worry about. So the position of the particle can be defined as this. Find the instantaneous velocity of the particle at 3 seconds. So I have my position function. And to find velocity, I need to take the derivative of the first position function. So I'm going to use the power rule, drop the 3 minus 1. So that's going to equal 0.34 times 3 is 1.02 t squared plus 1 times 2 is 2. So there's my derivative. Okay. Now, they want the instantaneous velocity, which means a picture, a snapshot of the velocity at 3 seconds. So literally all I'm going to do is take 3 and plug it in. X of 3 equals 1.02, 3 squared plus 2. Now, elementary people, you need to know how to solve this. Like nothing else before it do you need to know how to solve. But you should be able to get from here down because all that is order of operations. So for my elementary people, if you're like, whoa, I cannot even fathom these calculus problems, that's okay. But what you do need to know is that we're going to solve exponents first. So we're going to do 1.02 times 9 plus 2. Why? Because 3 squared is 9. 3 times 3 is 9. And order of operations says we do exponents first. Now I'm going to do multiplication next. So 9 times 1.02 is 9.18 plus 2 is 11.18, which is B. I told you I will always find a way to tie in my elementary people into these upper level problems, okay? Problem 7, same position particle, okay? Same position formula. So if we take this same chart that I drew up here, we're starting with our position function again. Now, I already found the velocity function for this. So the position is defined as this. I'm going to copy and paste all of this because we already found the velocity function, right? And this says find the average velocity of the particle. We already found the velocity function. So I'm not going to go over that again. We already did it. But this time they want the average velocity between 2 and 5 seconds. When we see average velocity, we can think of rate of change, aka slope. Now, we know, you and I both know, that a curved function does not have a slope. However, what we can do is between 2 points, we can find the average, which really we're drawing a straight line between those 2 points, and think of it like slope. Joseph, I love that you said that right at the same time I said it. Like, great minds think alike. So what I'm going to do is I'm going to do y minus y over x minus x. My elementary and middle school people, you need to know the slope formula. So there it is. We're getting ready to find slope between 2 points. So my y value is my function value. My x value is 2 and 5. So I need to solve this equation with a value of 2 and a value of 5. But then I can't forget to do my slope formula. So I'm going to already write 5 minus 2 on the bottom, which I know is going to be 3. I just need to find what those y values are. So I'm going to plug in 5 first. X prime of 5 equals 1.02 times 5 squared plus 2. 1.02 times 25 plus 2 equals 27.5. Now I'm going to go ahead and find x prime at 2. So 1.02 times 2 squared plus 2. 1.02 times 4 plus 2 equals 6.08. Now, this is the y value at 5, and this is the y value at 2. Because I did the 5 first, I need to do the 27 first. So 27.5 minus 6.08 equals 21.42 divided by 3 gives me 7.14. Woo-wee! All right. I noticed a few people in here gave me some suggestions for next week. So let's see. Praxis 7813, student errors with fractions. Okay. And Susanna, I have a student error problem prepared, another one. We will go ahead and do this one next week. So just so you know, like, I'm not forgetting you. I will also include a student errors with fractions. GK geometry. GK geometry word problems. Awesome. If you think of anything else, 3D geometry, we might do a geometry special here pretty soon. It seems like a lot of people need help with geometry. So we might do like a geometry special in the next few weeks. That's what we're going to do. We're going to do geometry special. That said, I am going to turn it back over to Dr. A. If you have any other questions, please let me know in the comment box. I love spending my Wednesday nights with you. And I will see y'all next week. Goodbye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.